But in this video, I only want to discuss rotational symmetry of quadrilaterals, four-sided shapes. In a previous video, which I made, discussed different properties of quadrilaterals. Right here, I want to illustrate this. If you just watch the screen. Right, so you can see what's happening now. I think what you might want to do, rather than focus on all shapes, just choose one shape, focus on one shape. Right, decide which shape you want to focus on. Right, keep your focus on that one shape. Watch. And back to where I started. Right. Did you keep a count of the number of times the shape fits on itself as it's rotating? Right. If you didn't do that, we'll try the second time round. Just keep a count of the number of times it fits on its original shape as it goes all the way around. Right, hopefully you kept a count this time. Right, what I'll do now, I'll choose one particular shape for you to focus on. You might have already done this, but the one I want to focus on is the rhombus. You can see the rhombus. Right here, rhombus. So I'm going to keep a count now. That's once, sorry, fits once so far, twice, back to where I started. So what we say is that the rhombus has got a rotational symmetry of 2. Now if you look at another one, let's have a look at the trapezium. Right, trapezium, right here. The reason why it's a trapezium is because it's got only one pair, one pair of parallel lines. So here we go, keep a count, keep your focus on trapezium. So far nothing. Right, it's upside down at the moment, still nothing. And back to where I started. So what we say is this shape has got no rotational symmetry, 0. Right, for some people it's obvious, they can look at the shape and determine what the rotational symmetry is. Now just by looking at it I could say it's 2, but just to confirm it, what I'll do is I'm going to trace the shape just to be on the safe side. Right, that's pointing up. To find the center, it's roughly where the two diagonals meet. I would say that's the center. Right, what I'm going to do now is put the tip of the pencil on that center of rotation. I'm going to rotate that paper, tracing paper, all the way around. And how will I know if I've gone all the way around? Well, look at that there, the arrow. That's the indicator. It's pointing up at the moment. So when I've got the paper going all the way around, it should be pointing up again, that arrow there. And while I'm doing this, I need to keep a count of the number of times this tracing paper shape fits on the shape that's behind. Right, here we go. Doesn't matter if you do it clockwise or anti-clockwise for this, it doesn't matter. That still hasn't fitted on. Right, fits once, or nearly, but that's just due to slight error in the center. That's one so far. Right, twice. That shape has fitted on itself twice as it's gone all the way around. And how do I know if it's gone all the way around? The arrow is back to where it started. So yes, it has got a rotational symmetry of 2. And if it doesn't fit as it's going around, in other words, it goes all the way around and then fits back to its original position, then you say it's got no rotational symmetry. Like for example, let's do some random shape. There. Let's just assume that's the center. I want to see how many times it fits on. And back to where I started. It's got no rotational symmetry.